Okay, and let me share my screen to share. So, can you guys see my screen?
Yes, sir.
I am no sir. I am just a student. My name is Azan. So, I am a 21 batch MTech student, sponsored candidate from Altair Engineering, and I have been working with my company since past 5 years, and I'm still working with them and pursuing my MTech in aerospace engineering. And I'm here to give you a very brief idea of how to use MATLAB. So can anyone tell me that they have used MATLAB or they are very new? Someone who knows MATLAB are there, or you are very new to MATLAB? Let me turn off my video. Hello?
I think us most of the undergraduate students up of first year and second year, they are not very well versed with MATLAB. Though
Okay.
I think some of them have learned it for some clubs, maybe robotics club if they require it, but I don't think many of us know.
Okay. Anyone from coding background who knows coding, or you don't know coding also?
Yes, we know second year students know coding, and first year students, I don't think most of them know it.
And very good. I also don't know coding. It's fine. Okay. So to begin with, MATLAB is, I can say, very less of coding, more of mathematical help for you to develop, uh, functions which is very difficult to do by hand. Like if I tell you to solve a 100 cross 100 matrix into 100 cross 100 matrix, it will take days for you to solve. This will solve for you in seconds. As simple as that. Uh, but I will say that it's not that easy to use it unless you start working on it. So I would say that everyone has MATLAB on their computer at least right now, or you guys are on mobile and you don't have MATLAB. Do you guys have MATLAB? You know how to install? Don't have it. Okay. Sherman says have. So those who don't have MATLAB, I say you take care, help of your friends, and please
As an,
install it.
you can ask them to use online compiler.
Yeah, yeah. Like whatever you want, you feel is okay. I'm not going to teach you how to install and those things. So just keep it handy with you. So to begin with, MATLAB, when you will open, it will look something like this. And here it will be your current folder by default, whatever you have, and the files in this.
Um,
Hello.
Azan, can you tell them the online compiler link as well? Can you share it on the chat?
Okay.
So
At the end of the session, I'll share with them. Okay. Okay.
they
So
have to follow along, right?
okay, sure. MATLAB online, but for that they need to log in through their basically, you know, um, start using. So you need to log in through your IITK account. So let me just log in. Sign in. Okay. Yeah. Open MATLAB online. Just 1 minute. Okay. So yes, using online. So you can go to this link, open, login with your IITK ID. If you have not created an account, you have to create an account. And okay, let me add. So this is how your online will look like. It is exactly same as what you see in your offline. There is no such big changes in that. So I'll just show you this offline part. So looking at the UI, you have your folder here, and whatever files you have will be written here. I have written some files for your help, and this is your editor, as it says. This is a command window and workspace. We'll get to it, what it does. So if I write something like 1 plus 1 here, nothing will happen. Even if I press enter or something, it doesn't work. So, but in command window, it's like a command. You are giving MATLAB a command to execute something on enter. So if you say 1 plus 1, then it gives you answer as 2. Now you can see that as soon as I pressed enter, there is something created here in the workspace called answer, and its value is 2 and its class is double. So whatever things you do gets stored and you can reflect them and see them here. So this is the workspace with which you can actually see what you are doing. So if I want to say 1 plus 2 plus 3 plus 100 plus 155, it will automatically do, and now your answer is changed. So this is use of command window. But now if you don't want to go line by line, you want to do some sequential steps and then execute them, then for that you have an editor. So in editor, you can write 1 plus 1 plus 2 plus 55 plus 145. And then if you select this, right click and say evaluate selection. So it will just evaluate this line. Now if I have 2 plus 3 plus 5 plus 55 plus 7, 8, something like this. And if I want to evaluate just this, you can just say evaluate selection. Now, if you click on run, it will evaluate both the lines. So you have to be careful with that, that when you click on run, it will go step by step, line by line, separated by enter, and then it will evaluate. Okay. And this is a very simple thing which I did. Now, when you write a mathematical code, you need to store some data, right? Like if you created an addition, you want to use that number on the later stages, you want to store them. Those are called variables, and variables are stored with certain names. So if I say a equal to 1 plus 1 plus 2 plus 6, and then b is equal to 6 plus 5 plus 4 plus 7 plus 8, and then c is equal to a plus b. So what it will do is it will evaluate a, then it will evaluate b, and then it will calculate c is equal to a plus b. So I'll just clear this, and then if I run it, you get a, b, and then c. Be careful that when you write these variables, it is very important that you don't use a predefined name. So what our predefined name is, MATLAB has some predefined functions, like you say dot. Dot is a return function. So how do you know that it is a return function? Because there are so many, and you might miss out on renaming a function with a variable. So what I prefer, usually this is a general trend, is if you are writing something, write with a meaningful name with a long number, and try to press tab after you write something. So if you say dot and if you press tab, if you get something here, so then it is a basically return name. Now if I press F1 on this, you see dot has come as a dot product of a and b. It is already taken, so you can't take a variable name which is already defined function. Okay, please be careful with that. I have can you make Varun Pant a co-host? Just hold on, guys. I need to do.
Bright red sports car, very fast. And behind the other two doors,
Yeah.
let's say for something that you don't really
Can you guys please
looks
mute
like a
yourself?
1 in 3 chance of getting your dream car. So suppose you pick door number 1.
Yeah, thank you. So I was where I was. Yeah, so please don't use predefined function names. It creates a lot of chaos. So now we will write a script. So here what we write is a script, and here what we write is evaluation. So let's write some simple scripts. So when you write a script, always remember that you are going to pass it to someone, and that person might not understand what you have written. So for that, you should fill your script with comments, because today you wrote some code with some mindset, and let's say down the line after 3 months you have to revisit that code to understand, okay, what I did. You yourself might never understand why you did this. So it's better to write codes with comments so that when you read it again, you have a meaning, okay, why I did this. So let's write a small code like something like, for expenses, I'll say income in INR. So how much do we get stipend? 12,500, right? And then you say these are my expenses in INR. So if you want to write a comment, you put a percentage, and whatever line you write, it becomes a comment. So what a comment is, it will not be evaluated. This line is skipped. It will directly go to stipend, and then it will say equal to, and then this value will be stored under the variable stipend. Then I'll say expenses. So you have hostel rent, whatever. I'm not sure because I'm not in hostel. Then you have electricity bill, some amount. Then you have water bill, right? Some 500. And you have cafeteria expenses, right? Okay. So you say 1500. So now I'll say, what are my savings? So you can do it two ways. I'll just do one more way, is my total expense is hostel rent plus electricity bill plus water bill plus cafeteria. And then I'll say okay. That's it. So now what I'll do is I'll just run the script. So now you see it printed only savings total, but all of my variables which I wrote, like cafeteria, electricity bill, hostel rent, savings total, stipend, total expenses, water bill, all have come here. So now if, because when you write a long code of 1,000 lines or something, you miss out which variable is going where or what are its values, you can always visit this workspace to see what value it has stored and where what value is changing. And if you see at the end of each line, I have put a semicolon, which is usually you do if you don't want to print that thing in this command window. So if I don't put here, and if I clear this command window, and if I run it, you see stipend is printed here and savings is printed here. This is a very strong thing about MATLAB, that if you just remove the semicolon, it will start printing in your command window, and you can see what are the values being changed or being stored in that particular variable. It is preferred to put semicolon because when you have long matrices or big data sets, you tend to print a lot of things, and that takes a lot of your memory. So it's better you put semicolon for the things that you don't want to print. And if you want to print something, you just remove the semicolon, and if you run it, it will do. Now, as you can see, I have to clear the command window again and again. It's very tedious. Also, you should clear your workspace before you start doing something, because it might be that it will take some old values from here and put it inside. It's very highly likely the case when I do my projects. I do some mistake, but it still runs. But then when I run in a fresh session, it doesn't run. Why is it? Is because some value was already stored here and it is using that value. But in a fresh session, that value does not exist. So certain practices which you should follow is write CLC. This is the clear the command window. So you don't have to clear it again and again. And clear all. This, I will say, it's not a standard practice. Don't keep it as a standard practice unless you are writing a fresh script, because there you create some dependencies between some commands, and if clear all is there, it will clear your data. So if I run this, you see ABC have gone now. And in this, I don't have to clear it again and again. Whenever I run, it will just clear this and just print it. And if I write CLC here, it clears this. So these are certain practices which we do, some comments and some basic lines of code which you can write to add something, subtract something, and some variables. Now we will move on. This is very basic. So we don't use MATLAB for accounting and all. I just wanted to get you a feel of what is a variable and those things. We will start with different vectors, or we can say matrices. So matrix is a collection of numbers. It can have n number of rows and n number of columns. So let's create a simple matrix of 2 by 2. So if I want to say mat1 is equal to 1, 2. So if you want to create a row, you just put comma and then press this. Now if I run this, you see it is a matrix 1, 2. You can double click on this variable if it is a matrix, and if it is viewable, it will show you how it stores the data. You have 1 and you have 2. If you want to create a column, you press semicolon. So each semicolon will be separated and then it will create a new column. So if I say 3, 4, and if I run this, you have 1, 2, and 3, 4. So now if you put this here, you have 1, 2, 3, 4, just like a 2 by 2 matrix. Then if you can also write it in this way in the next line, if you prefer to write it just to make it look like a matrix. But be careful when you use spaces and enters, because they have their special meaning in MATLAB. So I would suggest you guys not to go with next line and those things. You may do it, it's up to your convenience, but usually when people tend to do that, it creates some problems. So now you have one matrix. Let me create another matrix. 5, 6, 7, 8. I'll run this. So now I have two matrices. And if you want to add them, it's pretty simple. You say mat add is equal to mat1 plus mat2. And I'll put a semicolon here. So it will do element by element addition, just like normal matrices, and do it. I'll not do for subtraction, but now please pay attention. This is very important in matrices, is matrix multiplication. So there are two types of multiplication which people usually do, is a element to element multiplication. If you want to do like first element with first element, second with second row first with this, and this with this. So if you want to do such multiplication, I'll just say matrix dot multiplication is mat1 dot star mat2. Now if you see this, it is 1 into 5, 6 into 2, 7 into 3, and 4 into 8. That is your dot multiplication. But if you want to do a matrix multiplication, you don't need to provide this dot. So let me show you this. I'll just remove this and this. So you see dot has its own meaning. Let me increase this. Dot has its own meaning. And if you don't put a dot, it is a normal matrix multiplication like you do row into columns and that way. So please be careful while you use multiplication or dot multiplication. You should know what you want to do, and that is very important. Same thing goes with mat division. So mat division dot is element by element division. Mat dot division, mat1 divide by mat2. So you can see how it is divided and you have the output. But if I do mat1 by mat2, then it gives me a different answer because it's a matrix division. And while you use this dot, you should know that you have to do a dot multiplication. Now, a beautiful thing about MATLAB is vectorization. So if you want to just get the first row of mat1, first row of mat1 and add it to first row of mat2 and create another matrix. So what people usually do is get 1 comma 1. So there I can write it as mat3 will be mat1. Okay, before that let's do indexing. So if I want to get first one, so I say a11 is equal to mat1 comma 1. A21 is equal to mat1 comma 2. So this should be 1 2, sorry. So this is to extract each element in a particular matrix. So if I run this, oh sorry, it should be mat1 and mat1. Yeah, so if you want to extract the first element, you have to give the row index number and the column index number. If you want to give for any matrix, each time each element has its own specific numbers. So you have to tell that I want to extract this number and this. So now if I want to add this, and if I say b11 is equal to mat211 and b12 is mat212. So now I have first row 2 elements, right? Both the elements I have, and I have extracted that. Now I want to create mat3 as addition of the first row's matrix. So for mat3 is equal to a11 plus a12 comma sorry b11 and a12 plus b12. You see, it is so tedious to do because this is a small matrix, 2 cross 2. Now let's say if I have 100 cross 100 or 1000 cross 1000 matrix, and if I want to add, and if you keep doing this, how long it is going to take? So that's why we have vectorization in MATLAB, and this is very important because this is hardly there in any of the other coding languages, and that that's what makes this coding very stronger. So instead of this, I'll say mat3 vector. So before that, I'll say mat1 row 1. So if you want to extract all the elements of the first row, you just say 1 comma colon. Colon has a very special meaning in MATLAB. So when you give it with a matrix and you say colon, now you see this, it has extracted the entire row. Now if I give it some other dimension also, let's say 3 4 5 and 3 4 5 6, and if I run this, 1 2 3 4 5, okay, I need to give one more element here. Yes, now you see mat1 row, it has extracted me all the elements. I don't need to know how many rows are there because I am interested in the first row, how many of our columns are there. I'm not interested. So that way it makes your life really easy when you use this colon, and you don't have to loop through element by element when you know that you have to add the entire row. So just 1 minute. What is that? Why? Okay. So now we have row 1, and similarly I can extract mat 2's first row just by colon. So now I have both of them, and then I can say mat 3 vec is equal to mat 1 row 1 plus mat 2 row 2. So this and this. So it makes your operations really simple. Similarly, you can do it for columns. So if you want to give it in column, you give rows as all and columns as one, rows as all and columns as one, and then run this. So you will get a column matrix of basically these two. So this way, vectorizing reduces your looping problems because it understands that you want the entire row. Now, there are a few matrix commands which I will show you right away. So I'll say mat, if you want to generate a matrix of ones of some size. So you can just say ones and then you say 1024 cross 1024. And if you just run this, if you want to make, oh, sorry, if you want to make a matrix full of zeros, so uh, you can just type it as zeros and then run. Why is this going? So now you see you have a matrix full of zeros. Also, if you want to generate a matrix of random numbers, so there is a command called rand n, and I think so. If you just press run and give the size of the matrix, it will generate random numbers between 0 and 1. Or no, there is no as specific as such. So it is just random numbers and it fills in the entire matrix of random numbers. Now you see vectorization, why it is so much important. So if I create another matrix of random numbers, now if I tell you to add all the columns of these to the other columns of the first row, so it becomes very easy for you. So if you have mat 1 row is equal to mat 1 first row all columns, same way you create for second, and then mat 3 is equal to mat 1 plus mat 2 and then semicolon. So this way your mat 1 is a very long matrix of all these numbers which it has generated automatically in just one line. You don't have to extract each number, add them individually, and do it unnecessary loops in life, which will even enhance your process. And this process is very faster rather than looping through all the elements, adding them and storing it. So vectorizing using this colon and knowing when to use it is very important. Now you might be wondering, what if I want to just take half of the elements of mat 1 first row, half of the elements of mat 2 and then add them? You can still do it. So we know that the half is 512. So what I will say is, inside this I want 1 to 512 elements. So inside this itself you say how many elements you want. These are precisely the index numbers. just like what I told, 1 comma 1 is an index. So now you are saying that row 1, all these elements you want, row 2, all the elements you want, and then you add both of them. So like this, when you add, you see now your mat row has taken only 512, 512, and now your mat 3 addition is 512 elements of these two, first 512. If you want the latter 512, so you can start with 513 and then say till 1024 and then add them, and that way too you can index any number like this. So vectorizing is very important, and creating this vector smartly so that your operations are quick. So that is very important. Any doubts? Any questions? Nothing?
Like there was this command for mat1 equals random into 1024 into 1024, and before that there was like a zero. You had done zeros,
Yeah, so
and so
zeros
like
is to create a matrix of zero. So it is very important. Okay, why zeros is important, you are asking?
so like why exactly zero?
Yeah, so let's say it's a very easy thing. Sometimes you want to fill in some area of the
Oh,
matrix,
okay,
and others you want to keep it zero. It will come. So you are in which branch or anything?
I'm an arrow.
Arrow, right? Okay, very
Yeah,
good. So if you do numerical methods, okay, and when you want to check the condition number and those things, you will come under that. You have only first row and last column filled, rest all are zero. So what do you do at that time? I tell you. So this is the problem statement. Very interesting that first row and last column of a matrix should be equal to 100. Okay, rest all 0. So how do we approach this problem, right? And size of the matrix is 100 cross 100. Okay, so what to do? The best way to do is we'll say mat1 is equal to, first I'll create zeros of 100 cross 100, right?
yeah,
Then I will say mat1, and I want to assign to the first, right? First row, all
yeah.
columns should be equal to 100, correct?
Okay,
Mat1, last row, last row, sorry, what is that? Last column, right? So it is all rows and last column should be equal to 100, correct? Now you
okay.
see this. You have row 100 and your
The
last
last
column
column is
is
100.
100. Now on this you can do many things. In numerical methods they'll teach you what is condition number and those kind of things. We are not going into advanced things, but this way it is very important in real life also. When you will do some numerical methods, your matrix will be sparse. This is called a sparse matrix. So a sparse matrix is which has maximum zeros and very few entries in its matrices. So majority of the entries are zeros. So to create a sparse matrix, zeros is very important. Also, when you want to add some number to it easily to a row or a diagonal or that way, you first fill it with zeros and directly do these operations, which makes
Okay,
it easy. Same things goes with ones also. So if I say that the rest all are ones, then you can just make this as ones and then just run it. So you see everything else is one and this is zeros. So it is very important to have those two matrices.
Can we
okay.
write this for other numbers rather than 0 and 1?
It's very easy, no? If I
So
have
like
one,
you just have to write
multiply.
in words.
Or
Now
multiple
you say
2?
multiply by 100. Which one you
Okay,
want? So
Okay.
let me remove this. You want which number you want is you can just multiply by 100. So if you are creating zeros, then add by that number. That's it.
Okay.
Yeah. So see, mathematical coding is just not maths. You have to be a bit logical also. on how I can leverage what is already existing to make my life easy. So when we go into loops, I'll show you why vectorization is very important. Rather than I can write a loop also to do this. 100 times it will go and then it will fill it, but it is time consuming. Whereas this vectorization is very easy. Anything else? So I have a question for you. What is the matrix dimension always? What is the maximum matrix dimension one can get?
1024.
No, no. I'm saying the number of dimensions. Like you have 100 cross 100. Can I get one more 100?
That would be a 3D space. Won't
Okay. Can I get one more 100?
mathematically, I think you can get any number of dimensions.
Exactly. So you can get a 4D, you can get a 5D, you can get a 60. And it is pretty much possible that in your life when you go ahead, I have dealt with 3D matrices, and it is very important to know that 3D matrix also do exist, 4D also exist, and you shouldn't constrain because sometimes you might have to store these values when you deal with certain complicated problems, that you can leverage this, and that way your data structure is really amazing that you can store a 3D matrix. And now if you want to call the 3D matrix, it's not any rocket science. So if you want first element, first row, first column, it's 111. Its indexing remains same. There is nothing going to change between a matrix operation to matrix operation. And you can do matrix multiplication, matrix addition in all the ways that you want, but you have to be a bit careful that in what direction multiplication is happening. So that we'll cover in the advanced course, not today. But like a tab, like a lab, yeah, correct. You're right. So you can have n number of dimensions, and that way you can do it. One more important command which I feel everyone should know is size, because sometimes you'll get matrices and you don't know how much it is forming and you want to identify something. Is size in this matrix. So if I run this, so you get the answer. So if I say, let me just make it easier for you, this one, it has written 100 and 100. So first is the rows, so you have to say rows of mat1 is equal to size of mat1. Okay, let me store it as some variable x, and this is x1. So first element is rows and the second element is columns. Let me make it 2, and let me cover this and uncover this, and we have, let me make this 50 so that you understand. So 50 rows, 100 columns, like this. So size is very important. Another thing which I frequently use and you might need, if I run this, if I want to know where all my negatives are there and where all my positives are there, right? Very important. Or I know some value and I want to know that how much is less than this and greater than this. So important command, find. Okay, so find will return you the indices of basically mat1 less than 0. You see it has returned me the indices. Now what I will do is mat negative is equal to mat1 indices. My mat negative is entirely negative now. all these numbers are there, and where it is inside this position. But you know that the matrix is 2D. How I can get a 1D number, right? This is very difficult to understand. So if you do indices, and there is one more command in X, in Y. Yes. So this is your X and this is your Y. And this is how it is done. I'll explain you this going further. The find command, it is very important when we reach our other segment. I think we are running late. I need to rush up. Okay. So this was about matrices. I hope it's clear. I'll teach you the find command in detail in some time. Okay.
Hello, Azan.
Yes, yes, yes.
Yeah. How will we get a diagonal matrix from the
There's a
matrix?
command called diag. So okay, it's a good thing. Mat diag. So if you say diagonal, and then you give what are the diagonal elements, right? So you say 1, 2, 3, 4, 5, and run this. So you will get a diagonal element like this. Got it?
Yes. Thank you.
Simple. Same way. Another way is if you want to extract a diagonal. Okay. If you want to extract the diagonal of a matrix, you use diag and you pass the matrix. So it understands whether it has to create or it has to extract. So if you have already passed a matrix, it will give you the diagonal elements. And if you, so let me try this here, diag of mat tag, and close this. So it has returned me 1, 2, 3, 4, 5. So it has extracted the diagonal elements of this. Same way. Okay. Okay. So math, we know that it's all about numbers, numbers, and numbers. But sometimes you need strings to identify something. If I want to store some data, like let's say I want to store length, width, and height of a particular three objects, right? I can create a number of variables. That's but obvious. But to store it systematically and in less number of lines, or in a structured way, so that you understand, we have different data structures. So there is a matrix. Like matrix is a data structure. We have a cell and we have a structure. So let me begin with a structure. So I'll just say test struct is, so you create a structure by saying it's empty, and you just run this. Now it has something called field and a value. So if I say inside test structure, you create a field called object. Okay. And I'll say this is also a structure. Okay, sorry. So you see here, it has created a test structure. Why is it? Oh, sorry, it should be test struct. So it has created a test struct. So now if I print this test struct, it says that it has fields, objects, right? Inside these objects, I can create some, let me say, object 1, and its value is, it's a square. Okay. Let me print this. Now once this is created, now if I just want to see what is stored inside, what is object 1, then it will give me it is a square. Similarly, inside objects, I create one more object, which is object 2, which is a circle. And then I can create an object 3. This is maybe a rectangle. Pretty simple. Correct. Now I have three objects. So this is level 1 of a structure. This is level 2 of a structure. This is level 3 of a structure. So you see, in a structured way, you can store some strings inside this. You can store matrices inside this. You can store anything inside a structure. Like now you want to say that I want to store dimensions, right? So inside the same structure, I'll say now I want to store dimension of object 1. Correct. And that is equal to 200 x 200. And if I run this, now you see your test structure has two fields. We call these as fields, and these are their values. So the fields are objects and dimension. And there is no constraint that if one field had 3 objects, this also need to have 3. I can have 1. But then when I print this, I'll not have data regarding object 2 and object 3. But that's okay. I have not created it. That's why I don't have it. But this way you can store the data in a structured manner to access it in an easy way. Now sometimes you might feel that this is all inside. I don't know what is inside dimension, right? I don't know whether object 1, object 2, object 3 is there, or inside test structure itself objects and dimensions are there. So for that, there is a command called field values. So if you pass a structure, I think it's field values. Oh, I think field names. Yeah, field names. Yeah, it's field names. Sorry. So once you pass field names, you will get to know what are the fields. Now inside this, there are objects and dimensions. So let me say that I want to know the field names what are inside test structure objects. Are there any fields? Yes, I have 3 fields. So like this, you can check out what is the data available and what data is not available. I know that you can't view it here. If you open this, you can see it here inside this. So you have a test struct. Inside test struct, you have a test object. And again, if you go inside dimension, you have object 1. And that way, in a structured manner, you can store this. There is another thing which is called a cell, which is very important. So I'll just say test cell. So when you want to store a combination of strings and numbers, you should go for cells. So you have test. I've created a test cell and it is denoted by curly braces. So in MATLAB, each special character has its special meaning. So be careful when you use them. So if you denote something by curly braces, it itself understands that it is a cell now. It is not a matrix. So if I want to create a matrix, I have to say square brackets like this. And if I put it curly braces, it will automatically understand that it's a cell here. So you see test cell, cell, and its class is cell. Let me put a semicolon here. Now inside cell, if you want to index it, it is similar to what we have in matrix. You can have 1 cross 1. And I say this is object 1. And same way, I can create, I have given first row entirely to this. So I'll take second row entirely to object 2. And then I'll say 3, 2, 3. Okay. And now inside that, I'll say test cell 1, comma 2. So first row I have given it to object 1, and that way I'll just store that 200 x 200 and 2 comma 2 is, I will just have the radius, so I'll just put some 5, and I'll just put a number also. You can put a number 5, and in 3,2 I'm putting a rectangle, so I'll say 500 cross 200. So now if you see my, let me just show you my test cell, how it looks. So if you say test cell, it looks like this. Object 1, this, object 2, you see you have a number now with a string and a number and a string and a string. So now in the same way we were vectorizing this, if I say test cell 1 comma colon, it will give me both the values, object 1 and this. And if I say 1 2 comma colon, it will give me data regarding second, third, then data regarding third, like that. So these are different data structures which you might have to deal with uh, when you deal with strings, which are very important because sometimes you get data from somewhere which has strings and you need to sort them accordingly. So this way your data structures help you. So any doubts in this? Or is it too confusing?
Could you show the output for the last one again?
Test cell.
Yeah,
Sure. Yeah. This is how a cell will be.
okay.
So this the good thing is because we can't store strings in matrix. Matrix is pure numbers. You can't have a string in a matrix. So these are usually to store strings and numbers together, which are related, right? That kind of thing. Good. Any doubts? Any doubts? Nope.
Um, one, d-
Yeah.
I have one doubt. So like there was a rand in command to
Yes.
generate random numbers.
Yeah.
So is there a similar command for strings?
To generate random strings?
Yes.
None that I know of. There might be. MATLAB is huge because I am not an expert on this. You can search, you can Google it anytime. But I don't know anything.
Okay.
Yeah. So related to strings, there are lots of commands like you want to find a string in a cell, then you want to match a pattern and those kind of things. But if I go there, my 1 or 2 hours will go. So I'm not going deep inside that, how to handle strings, because that's not the agenda today. I might cover it in the advanced session.
Azan, can you explain the meaning of line 6?
Pardon? I'm not able to hear you.
The meaning of line 6?
Line 6. 666 here.
Yeah.
So I am creating a structure inside a structure. Okay. So if you see my structure, you see this is a structure. Inside, you see it's so, okay, let me not confuse you with this. So if I create a struct, okay, let me create an empty struct. So now if you see this has nothing, right? I can directly put some values inside this. So I'll just say test struct has something called value and it is equal to 1. Okay, you see directly it has filled in value, but you see this symbol, it is a matrix. It is not a structure, correct? What I am creating is a structure inside a structure inside a structure, and that way you will have so many structures. So when I run this, if I open this, you see this is a structure, this is a structure symbol. Can you see that? Like this
Yeah.
and line. So this inside this again you have some values like this.
Okay.
Okay, so the good part about structure is you have sub levels. It's like a tree, you can think. So you have one higher level, inside that multiple, and like that. Sorry, Himanshu, I was not known that this was scheduled for 5. I'm not sure. I will give you the recording. You have not missed out on much except the matrix part, but yeah, I'll share the recording. So that You got the point
So
about
it's like,
structure?
it's like one single field can have many values.
Yeah, let me show you. Okay, so let's say you have master here. Okay, this, let me say this is my structure. Okay, it is actually like a table like this. Inside that I have slave 1. Okay, now inside this I can have multiple correct values stored. Let's say length, width, and height. Got it? I can have a slave 2 which can just have radius because it's a circle. Okay, and again I can have slave 3 which has length, width, and height. So this is the beauty of a structure. First of all, you don't have to maintain same dimensions. Okay, and you can store any data with any name under any value, any size. So that is the beauty of structure. Are you clear, or you are still having
Yeah,
some
clear.
doubt?
Yeah, can you show that like the editor where you have written? Once again.
Pardon?
Can you show the editor where you have
Yeah,
written that?
yeah,
You
yeah,
have written
yeah.
it?
Sure.
I may have one follow-up question. So, you said that test underscore struct object. So you said that there is one more struct objects inside
Correct.
test structure.
Yeah.
Okay. You are giving the like the values like inside objects. There is object 1 which is square, object 2, object 3, right?
Yeah.
One more thing. The predefined like struct is the predefined thing,
Yeah.
right? The
Struct is a predefined function.
Okay.
So when you say struct and empty, it will create an empty struct. Actually, inside this, I can give objects, object 1 and square, but it becomes very tedious. So I prefer to do it this way. There is another way. You can give field value, field value, field value like that.
And
Inside
same
struct.
goes for line 12 also, like the
Exactly.
uh,
You can give inside this also. So I can create a cell inside a cell. I can do that, but people might not understand that. That's why I try to keep it simple.
okay. Thank you.
So many messages. Okay. Sorry guys who have missed out. I think there was a miscommunication regarding 5 p.m. It was on 4 p.m. but that's okay. I'll share the recording with you guys. So shall I move on? So this was data structures. We are not here for strings. I could have included that. Sorry, but it takes a long time to understand strings. So in MATLAB. So let's move on with loops and conditioning statements. This is something which you should avoid, but sometimes things are unavoidable in life. So let me clear everything. Close this. So there are conditioning statements and looping statements. These are basics of a coding. So if you want to run a loop n number of times, you do looping statements. So to list down a few, let me show. Okay. If you know how many times you want to loop, you should use for. This is, you know how many times. Okay. Pardon my handwriting. Writing on computer is very difficult. Now, second is, if you know when to stop, but you don't know how many iterations it might take, right? So there can be a scenario where you want to stop at a certain condition, but until then, don't stop. Like you have a curve and it keeps on growing and till it reaches like almost zero value, that let's say 1 e power minus 19. Till that you don't want to stop. If you don't know till when you should stop, you should use while loop. While. So when you know when to stop. Okay, and there is a specialized version of while is you want to enter inside the loop once, at least one time you want to do, and then check for condition and come out. So that time it's do while. So the difference between while and a do while is this will be executed at least once. We'll see that. And it doesn't matter actually if you provide the condition. People don't usually use do while, people usually use while and for. Okay, so now what we will do is I want to create a matrix of 10 by 10. Each element should have a value which is equal to the sum of their index. So you got it? Like if I have a 10 by 10 matrix, correct? I want that if it is 1 comma 1, the value should be 2. 1 comma 2, value should be 3. 2 comma 2, value should be 4, like that. 10 comma 10, value should be 20. Okay, this is a special problem. So now I know how many times I have to loop. I have to loop 10 times and I have to loop 10 times. What I will do is I'll say create a data matrix, which is you can create an empty matrix or create a matrix of zeros. So doesn't matter now. So what I'll say is for. So when you write a function like this, you get a for statement. Now you have to say how many times you want to run. But for that, you need to put a condition. Okay. So you have to run for so many runs, right? So I will say that for my row index, which starts from 1 and goes up to. So here colon is to. So if you don't know that, let me show you. So if I say data mat is equal to 1 is to 10. So if you want to create a matrix of 1 to 10, you just put is to and then it will create it. So if I run this, it creates a matrix. Now, how did it assume that I want to go in steps of 1 only? Because it's a default value. Now, if you want to define the step, you say 0.1 and then put is to and then run it. So now you see it has created my matrix from 1, 1.1, 1.2 like that. So this is to here is very powerful to create a matrix of n number of steps. So now what I want is I want my row index to start from 1, go in steps of 1. You can put this, but default is 1, so I don't put it, and go up to 10. Okay. And then you say end. So this loop will go and put row index value 1 to 10. Now I want to move in columns also. So I'll write one more. I'll say my column index is equal to 1 is to 10. And then I'll end this loop. Then I'll say data matrix of row index, comma, column index. So what this will do? First, in the first loop, it will start row index is equal to 1, column index is equal to 1. Go inside this and put the value is equal to row index plus column index. So 1 comma 1 will become 1 plus 1, that is equal to 2. Then it is still inside this for loop because your column index has not reached value 10. So now it will increment the column index by 1 and then it will make it 2. Then 1 comma 2 will be filled as 1 plus 2, that is equal to 3. And like that, this will loop on for 100 times. So let me, I've put semicolon and then I'll just print my data mat here or not, because it's a big matrix. Let it be. Okay. Now you see data mat. You have each of the index is equal to sum of the index value. Got it? Any doubts in the for loop?
Azan, in line 7,
Hmm.
you have like declared this, right? Data underscore mat, like this is a matrix.
Empty matrix. It's an empty
okay.
matrix.
But
So
why don't you declare row index and column? In
Pardon?
MATLAB, we don't declare variables.
You don't have to upfront declare it, but it is advisable for it to be declared upfront if you want your process to be faster. So if we go back to the level of coding and speed assumptions, so if you are a good person who wants your code to run fast, if you are going to you know that it is going to be a matrix, then declare it upfront that it is a matrix, then your solution becomes much faster. These two I learned very recently. I too didn't used to do it. So if you don't put this also, there's no harm. It'll run. But if you see, there's a warning here. You see, consider pre-allocating for speed. So if you pre-allocate it, it knows that it is this. Also, if I want to make it much more faster, I can upfront create a zeros of 10, 10 because I know that it is going to be of a size 10, 10. And now the warning has vanished. Can you see that? Yeah. So that way it is faster actually. So now you are dealing, I'm dealing with very small matrices. In real life scenarios, it's very big. Like I have dealt with 8196 cross 600 cross 600, and these are huge matrices. So at that time, if you pre-allocate, right, you will see a significant number in speed. Any other doubts?
Thank you.
Okay. So did you guys understand how this works? I hope you guys understood that how for loop works. So I can increment it every 0.1 also, but then index will go wrong. So it's not correct. But usually avoid doing this if you can vectorize it. Okay. So I don't know. I currently can't think how to vectorize this, but we can vectorize this also. If we can vectorize this, then just write one line and you are done. Your MATLAB will internally loop it for you. You don't need to do that. Okay. Now, uh, what should we do? We need a while loop, right? Okay. So, when you know how many iterations it will take, but you don't know when it will stop. So at that time, you should use a while loop. Which example we can use of a converging something? So let's say you have to reduce one number from other till it reaches 0 in steps of 0.01 or something like that, and you don't know how much time it will take. So at that time you can use a while, but that will take some time for formulation. I'm going to skip this, or let me try it. Okay.
Azan, can you
Yeah.
undo it? Someone in the chats asked, please explain the line 12.
Okay, sure. What was the line 12? Line 12? Who is that? Mohit.
Yes, Mohit asked that.
Mohit, yes. Okay, Mohit,
What is in that bracket?
inside this.
Yes, sir. It is
So I told you, your matrix has indexes, right? These are indexes. So this element has a entry 1 comma 1. How do you mention in matrix? So this is 2 comma 1. This is 3 comma 1, right? So what I'm doing is at each element in the row across the index. So I'm moving in rows and then I'm moving in columns. Got it? Or okay, it's very easy for me to make you understand. Row index, I'll print it. So what it happens? Let's see. Okay. Now, where is this at? Okay. Yeah. Mohit, can you see this? So in first iteration, it was row index is equal to 1, column index is 1, right? So in data mat, 1 comma 1, 1 comma 1. Okay, let me put an error here. So now, okay. So now you see your data mat. 1 comma 1 is assigned value 2. Got it? Now in the next iteration, it is a iterative process. Your for is a iterative process. So it will increment the value of column index by 1. Okay. And now your column index will become 2. Okay. Now let me say if call index is greater than 2, then break. Don't worry about this, guys. I'm just trying to explain him. So now you see your row index, correct, started from 1 and 1, correct. Then your column index became 2, means 1 comma 2 it will assign here. Got it? Then 1 comma 3 will be assigned here. So this is how you move in a matrix across columns. Once it reaches 10, it will terminate and go for the next row, because it has to loop across all the rows and all the columns. Is it still confusing?
No, sir, got it.
Got it?
Thank you.
Yeah, no problem. So this is how you can loop for this thing. Let me just, so while is a loop. So when you say while, let me say some x initial value is 10, x final is 1e minus 19, not minus 19, it will take a lot of time, 1e minus 5. Okay. So now what I want is, when my, let me say x calculated, I have to reduce x from 10 to 1e power minus 15 in certain steps. Okay. And I don't know how much iteration it will take, because it's going to be huge. So you can use a while loop. So what I say is, while x calculated is greater than x final, what you do is put my x calculated is equal to whatever value is their initial value minus 0.1. Okay. And then end. So what I'm going to do is, let's check the number of iterations. Iter is equal to 1. Iter is equal to iter plus 1. Run this. Okay. So can you see this? So what I did is, I have to reduce 10 in steps of 0.1 till it becomes less than 0.0005. Okay. And in that way, I started with initial value as 10. And I said that till the time my calculated value is greater than final value, you go inside x calculated and reduce it by 0.1. And I'm just keeping a track of how many iterations it's going to take. So now in first iteration, what will happen is x calculated is equal to 10. 10 minus this, it will become 9.9. 9.9 is greater than this. Yes. Then it will go again. It will keep on reducing, keep on reducing, keep on reducing till it reaches this value. And this way, till the time it satisfies this condition, as soon as this condition is satisfied, it's going to come out. But the thing is, sometimes people tend to miss this condition, and your loop will go into infinity, and it will go inside, you know, hanging mode, so that you have to quit the application and then you have to restart. So while is a very tricky loop to use, but sometimes it's inevitable, because you don't know when it is going to converge the problem. and that time while is very important. So be careful while using while, and also keep break statements, which I'll teach you in some time, so that you can break it if certain condition is satisfied also, like that. So yeah.
Is it necessary to use end?
Yeah, so it doesn't know. So if I keep it open, it doesn't know where to use it, where to end, right?
So if I
Because
don't put n, it
no,
will go in infinite loop.
no, it's not that. It's a syntax error. Why? Because
Okay.
is I want, if I put now I want to say iter is equal to iter plus something, like, right? I want to use this. So it doesn't know that it is inside this while or it is outside the while. You're getting my point.
Okay, okay,
So
okay.
to make MATLAB understand that my loop is ending here, do these things inside the loop. These things are outside the loop, like that. So end is not to end the loop. End is to understand that these statements you have to execute in the loop. Anything else? Any doubts? Someone else, please. Okay, Mohit is okay. Any doubts? Okay, I hope no doubts.
Also in the
Yeah, sorry.
like in, if I want to know the final value of iter, I'll have to call it within, from within the loop, or like, I mean, won't it return the global value of loop from outside if I call the value of final value of iter after the loops?
I didn't get you.
Like
So
after
this,
end, if I
yeah.
ask it for returning the value of iter,
Hmm.
won't it give the initial value of iter, or
No,
will it
it
give the
has incremented, right? So I'll let me print this. So iter is 101. After 101 iterations, it has stopped. It has converged. It was 1, and after so what happens is, see, this condition is not satisfied, so it will go inside, correct? So 10 is greater than, it is satisfied, sorry, correct? So once it is satisfied, it will go inside and reduce xcal, and it will make it 9.9, correct? And iteration will
Yes.
become 1 plus 1 is 2, second iteration.
Yeah.
Now in second iteration, it will go here, then it will make it 3, 4, 5, till 101 it is going, and then it is coming out. That's it.
Okay.
Run. Why did you mention another variable xcal or xin?
No, that's okay. I just got confused. Nothing. It's nothing. You
Okay.
can use xion also. It's fine.
Excuse me.
Yeah.
Can any shortcut be applied for incrementing it, like plus iteration plus is equal to 1 in place of writing
Yes, there
iteration?
is INCR. I guess so. INCR iter. I think so. Or no. There is I think iter plus plus. I don't remember.
Yes, that
Yeah.
one.
Yeah. I'm not sure. Or iter plus. There is, I think so. So iter plus is equal to iter also is there, but I don't remember. I usually don't use.
Is it like iter plus equal to 1?
Yeah, I think so. Yeah. I'm not sure, but yeah, it is there. There is a shortcut.
Semicolon, you didn't put the semicolon.
Is
there.
it?
Like iter plus then 1 semicolon.
But it is not taking it. If it becoming purple, then it is identifying this as a function. There is, I think so. There should be INCR or something. Increment by 1. Let me check you. I'm not sure. There should be. So iter is equal to iter plus 1. Anything else? Okay. Then we'll go to conditioning statements. Very important is if. So let me go to my whiteboard. Clear this. This is a condition statement. So let's take some variables. So you have a equal to 10, b equal to 10, c equal to 8, d equal to 12. So now if you want to check some conditions, that, and then only proceed with certain statements. You have to use if, and then the condition, then your statements, and then end it. Okay. Like if you want to check that if A is equal to B, then you do C is equal to some E is equal to A plus B. Okay. Let's do this. A is equal to 10, B is equal to 10, C is equal to 8, D is equal to 12. Now, first is if A is equal to B, then what you do is addition value is equal to A plus B. Okay, and end. Do you think this will run? Anyone? Hello?
No, it shouldn't, like if there should be this comparison operator, right? A double equals.
Pardon?
Shouldn't there be A double equals in line?
Exactly. So as you know that A equal to is equal to already has a meaning. Equal to already has a meaning because we have already done it for assignment. So for checking of equality, there is equal to equal to. So if you ever want to check a equality between certain values, you should have equal to equal to. Now if I run it, if A is equal to B, yes, it has went inside. Now same thing, these are simple. So if A is greater than C, run this, it is. But if A is greater than D and if I run it, there's nothing because A is not greater than D and it has failed. So this way you can give values that is greater than equal to as well. So you can put greater than equal to, less than equal to, and importantly, there is not equal to. So not is presented by this. Oh, sorry, it's tilde, not equal to. It's a tilde symbol. So tilde is given as not. So if it is not equal to, you have to use this one. So this is done for your conditional statements. Any other doubts? I think this is pretty simple, not that complicated. Okay, now we will move to something which I like, that is reading of files. So why reading of files is important is you may get data in terms of Excel sheets, you will get it in terms of comma separated files, and that will be a huge data. And if you have to read that data, we have some already made commands in MATLAB, which you can easily use. I have created a sample for you, but we will take one more file. So this is a very small file which I have taken, which has text as well as data. So there are commands called XLS read. Preferably, this runs only on Windows. It has its own limitations because it needs Excel to be installed in your version. It launches Excel, reads the data, and returns you. Okay, so XLS read, I will just say sample.xlsx. Okay, so this is the one. Now, if I write sample.xlsx, you see this is the current folder. It should be inside my current folder. Now, if the file is outside the current folder and if you want to call it, you have to provide the entire path. Okay, so please be cautious with the paths that if you have the file inside the directory, then only you can call it just by its name. If you don't have it, you have to paste the entire path to it. Now, this returns some 3 values. We'll see what are those 3 values. Let me run this. And it's a time consuming process. Yes. So you see it has returned you a matrix which has just the numbers. it has returned you a cell and it has returned you actually two cells. So let's see them. What are they? There is a matrix which has contained all the numbers which it read. There is a B matrix which has read only the strings, and then there is a C matrix with the entire data. So with just one command, you get all three data in one shot. Now, what if you have a data and basically strings in between? So what I'm gonna do is I'll just put some ABCD here and some 200 here. Okay, let me save this, close it, and run this. Now, if you see, you have nans, and this makes life very tricky because you have to identify each element, which element was nan and not nan, and segregate them and understand that what value it was. Instead, I prefer to use C. C has the entire data now. So I can store it either inside a structure or inside anything which I want and get it. So how to identify that whether the element is a nan or not? Like, how do I do it? You can use that equal to sign, that is equal to nan. Nan is a special name, so don't use it. Or you can use is a. So if you want to explore how many commands are there, you can just say is and just tab. So if you press tab, you can see whatever commands are there with respect to is will come here, and there are too many. So let me check if there is a command called is nan. So can you see is nan? So if I say is nan, what is the matrix? I'll say a of 1 comma 1, a of 1 comma 1. It will say logically 1. Yes, it is true. So while assigning, if you want to check that whether it is nan or if it is infinity or if it is a null value like that, so you can use is functions. Is functions are very important in MATLAB, and that way you can actually check. So there is, I think, is INF. Yeah, there is infinity also, and then there is a function. So if I say if a is it a double? Yes, a is a double because it contains only numbers and nan. Nan itself is a number which does not have any value. Okay, but if I say is a cell, then it will return me 0. So is functions are very important when you are going to segregate this data. I'm running short of time, otherwise I would have shown you how you can actually put this inside a structure so that you understand structure also properly, but I'm running short of time, and I'll try to cover this in the advanced session. But XLS read is a very powerful command, but make sure that whenever you get data from someone, try to tell them to save it in a CSV rather than a XLS read. So let me tell you what a CSV is.
Azan,
Yes.
can you please explain why did you write a matrix ABC?
Because I know that it returns 3 arguments. So XLS read is an internal command. Okay. So if I press F1 on this, let me open its help. So you should read this help always. So you see it actually returns num, text and raw. I know that it returns 3 outputs. So that's why I gave them names as ABC. Okay.
What will happen if you write just AB?
So it will just give you AB. It will not matter. It doesn't matter. It will just store AB. You'll miss out on C.
Okay.
Yeah. So with AB also you can work because you have strings, you have the data, you know what is where. You can work that way. That is also a good thing. So let's say if a function is written, that will move to functions. When I explain functions, I'll explain you that. Okay. So where was I? Yeah, CSV. let me show you what a CSV is. This is one of the most used in the industry, comma separated file, comma delimited file, sample save. Okay, so now so if I open this, I'll open it in a text pad. So can you see length, comma this, width, comma this, height, comma this, and this, like this. So it is separated by commas. So there is a function called DLM read. Okay, let me show you its help. So when you say DLM read, where is the DLM read? DLM read, yes. So DLM read can only read numbers. Okay, so that way you have a shortage that you want to read number or only strings or that kind of thing. So if you want to read a string, you say read, XLS read is very powerful. But if you just have numbers, I say you go with DLM read. So that's called a delimiter reader. Delimiter is something that separates the entries.
Happy anniversary.
And then
Happy anniversary.
okay, yeah, so DLM read is one more command, and if you know that it is comma limited, then you can use CSV read. It is same as DLM read, but it knows that the delimiter is comma, so that way. And if you have matrices, let's say I'll create A is equal to rand n of 100 comma 100. Now I want to write this to a file. You can use XLS write, same command, but it will work only on Windows, not on Linux. It has its own problems. So what we can do is we can say DLM write, because it's only numbers, and then you say the file name. Okay, I want to create new sample dot CSV, and then you write what is the matrix you want to input. I say my matrix is A, and then it is asking for a delimiter. So by default, the delimiter is tab. So it will store each value separated by tab. But if I say give my delimiter as a comma, and if I run this, it has finished the task. You can see here a new sample CSV is created. Okay, let me open it in TextPad so you understand. So you see each line, each value is separated by a comma and exported to a file. So this way, entire matrix in one shot has been written to a file. Any doubts?
I had one doubt, like when you are writing this DLM write new sample.csv, so like are you all creating a new sample file
Yes.
beforehand and then
No,
writing to it?
it will do it internally. You don't need to do that. So you have to make sure that that file does not exist. Very important. Good point. So if this file exists already, it will replace it.
Okay.
Okay, so you make sure that it doesn't exist, and then you write it. So you don't have to create it. It will automatically create for you. And if it exists, it will basically overwrite for you.
Why are there commas after like delimiter, comma, and comma?
So it's a common, so there is CSV is comma separated values. It is a very common file exchange between people in the industry. It is a very lightweight, and it can be viewed in a text pad also, like I shown you. But if it is an Excel file, you have to have Excel for that. So that's why I have given delimiter as comma.
Okay, so you mean that the delimiter here are commas? That's
Yeah,
why
delimiter is a thing that will limit your value and separate two values. You can think like that. So there, so let's say if I don't give a delimiter, what happens, right? So let me show you. And here, now if I edit, you can see okay, so I think by default it is comma. I can, let me delete this. Cancel. Why is it open? New sample one. Let me create this. Okay. Yeah, so by default it has put commas in between. Now what if I want some tabs, right? So there is a way, I think it's \t. Run this new sample.csv. You see it has separated by tabs now. So this is actually a tab. Yeah, so usually what people do is they store it comma separated, and that's how the exchange happens between people, and it's a very lightweight file. When you want to share numbers across, so that way it's very easy and handy. Any doubts?
Thank
you. Yep. So that was for importing and exporting data. And now we will move on to writing functions, which is very important. So think like you have a car. If you had to assemble it every day to run it, it's very tedious. If you have a bike, if I remove all the spare parts daily and you have to go assemble it before running it, it's very difficult. So functions are like an assemble bike, which you can write anytime. And why writing functions is very important. Modular functions, which does not have dependency on anything, is very important. Is you can pass it on to one person to other, take it on one project to other. Like I wrote some modular functions back in my first semester, which I'm still using it in my second semester. But if I don't write them as functions, and what we did, like like writing like this, I can't use it across projects. It's very difficult to adapt to it, because you would have written it with some mindset and it doesn't actually behave like it should. So writing modular functions is very important, and I'll teach you a very few basics of how to write a function. We'll write very basic functions, and with that we'll finish this session. But we'll not go on higher end of functions. I am not going to write a very complicated function, but I'll just show you how complicated a function can be and why is it very useful. Okay. So let's write a function just to multiply two numbers. Very easy. So to define a function, you should say function and its name. Remember, just like variables, you can't write a function with the name of a function which is already given by MATLAB. Otherwise, it will override that, and then you will not be able to use the function written by MATLAB, which becomes very problematic because you might use it. So I'll just say multiply num. Now, multiply num is its name, and then you end the function. That's it. So to call someone, you have a name. So to call a function, you have its name. Now, your function needs some inputs, right? So like I said, XLS read. So if you see XLS read, XLS read. Yeah, you see automatically it says that it needs some inputs for XLS read to be executed. Like that for our function too, it's not mandatory to have input arguments. Sometimes some functions work without input arguments as well, but it's preferable that you keep as many arguments as possible. So I'll just take num1 and num2. These are my input arguments. So what I say is my mul num is equal to num1 star num2. Or for a better thing, we'll do division, because that way we can put some statements also. Okay, so we'll just divide it. Right now, I have to get this value inside, right? Because if you see now XLS read, when I wrote XLS read, it returns some value. F1, 1, yes. So now this is returning me some value. So how do you return it? So if you write that I want this variable to be returned, right? So this is becomes your function definition. Very important. Your return value in square brackets is equal to your function name followed by bracket and your input arguments. So now I will call this function. Always remember function definition should be below and its call should be above. I know it's very tedious, but this is how it is. So if I want to say my A is equal to 10, B is equal to 20, and what I want is C is equal to division num A comma B, correct? And if I run this, I get my C as 0.5. Pretty simple, right? Now I can use this function anywhere. I can give it to anyone. They can just plug in two numbers and they will get the output. Division is not required, but I'm just saying that it is that simple to create one function. Now, is this function good enough for division? Anyone can say?
So we should define if num2 is 0.
Exactly. Very good. So we should say that if num2 is equal to 0, then what should you do?
Return an error.
Yeah.
Okay. Return an error. Anything else?
Not defined.
Say invalid.
Infinity.
Anything. It's up to you. Okay. So there are certain things you can say error. Division by 0. Okay. So error is a internal command which will print an error and return from there and not do anything. So let me try that. You see, division by 0. And it will say that where is the error, like that. Or if you do that, then you can just say other way is mulnum is equal to INF. It's infinity, right? And just say return. And you run this. So C is automatically infinity. Now, what if I want to multiply n numbers? Right? Very important. Sometimes it can be a case, very rarely, but not so often, that you have n number of arguments. Let me show you first how complicated a function can be. Okay, where is this trapezoid or Newton Raphson? Maybe something. Okay, Romberg integral. Okay, where is my computation? So this is back in first semester. I wrote some commands. Okay, so if you see, this is the function. So it's not that simple, right? You can't just do it. But if someone tells me today to do bisection method, I have the function ready. You give me any input, any x min, I can basically iterate. Now, the thing is that what if you don't know how many inputs you are going to get? Very interesting problem. That I want to basically multiply n numbers, right? Let me remove this. So I'll say mul n nums, correct? And I know the output is going to be just one number. So there is a special command called varg in. I think so. Is it varg in? Varg in, sorry. Okay, this is a special name which is given for variable arguments input. So it's varg in. Okay, and I'll end it. So what we will do is we'll just pass it to this and will not return anything. So let me just say mul is equal to 0. We'll just puts the varg means print the varg. So let me print, and you can see that varg automatically takes a shape of a cell of that particular numbers which I'm going to pass. So now if I pass, let me say c is equal to 100, d is equal to 20, and I pass it to this, it still takes it because I have said that there can be variable numbers of argument, right? Now what I will do is I'll write a function to do this. So let's say total numbers. So how many total numbers I'll get is whatever will be my length of my varg is going to be my total number. Now for I'll say index is equal to 1 till the total number value is equal to 1. I'll say 1, yeah, is equal to 1 total num, and then end mul value is equal to mul value into varg of that index. Are you guys following? So what I'm going to do is first I'm getting the length of total number of arguments. So I'll get 4 here. I'm initializing the multiplication value as 1, and I'm looping through all the numbers to multiply it and then just return that multiplication value. So let me just put this as 1. And now if I run this, you see your answer, basically I can say value is equal to. So your multiplication value is this. And now if I pass any number to this, and if I run it, it will do its multiplication of any numbers. So varg in is a very powerful thing which you might have to use it, and there should be some checks on this, that if varg in is 0, then it should give error that the length total number is 0, then it should just give error that there are no inputs. So as in when you start writing the functions, you will see that where it can fail, and for that you put checks, you put messages, you put comments inside this. You don't write a function like this, you write a function at least like this. So what I am doing, what is x, what is y, what is this, and those type of things. Any doubts on this?
Can we, like in functions, can we do stuff like calling other function within a function or
Yeah, you can
recursions
do. So like I can create a function to multiply 2 values and then pass these 2 values to that function, and that will return me a multiplication value. So you can do that, not a problem. And provide the thing is that sequence of the function doesn't matter. It does not matter that if you are calling one function, it has to be above that function. No, you can write all the functions and call them anytime, anywhere.
So it does not matter that I have to call the I have to like define the function
No,
before calling it.
no.
Or
So I'll tell you how the execution works. It first evaluates, it will go through the script line. If it finds function, it will store what is there inside the function every time. Then it will evaluate what is there. So till the time it comes for evaluation, all the functions will be defined. So you don't have to worry about that.
Okay.
Yep. Any doubts? There is a varg out also. So when you don't know how many outputs might come, when your outputs also depend on your input, then you can do VARG out also. I'm not covering that because we don't have that example as of ready now, and people don't use VARG out much. Okay, I think Devansh, you asked about that. What if you use A and B, right? In that. Okay, so there is an important thing that sometimes you write a function which returns multiple values, right? Like say your XLS read, what we had, it used to return ABC, A, B, and C is equal to XLS read. Correct. Now you don't need C, but sometimes you need C, sometimes you don't need C. If you don't need C, just put a tilde there. Or if I don't need A and B, I just need a C. Just put this. Let me just evaluate this section. Oh, what happened? Oh, sorry. And close this. What happened? Functions definition. Okay. So it has just given me C. Okay. The first two arguments it has nullified. So you can use tilde for whatever. So tilde is required. And that way you can nullify why this is required. It's very important. Don't unnecessarily store variables. Okay, it takes up a lot of your memory. If I show you my memory currently, which is going on, your MATLAB is going to consume the most of it. Okay, so where is my MATLAB? Here, MATLAB. You see, it's going to consume most of my memory because that is being stored there. And that way, if you unnecessarily store values, it's going to cause your script to slow down, computer to slow down, and not good. Your script just not should be efficient, it should be fast also. That will come with practice. It does not come overnight, but that way you should make sure that if you are not using that variable, just put tilde and move on. That's it. And use semicolon at the end. So very important because unnecessarily, okay. Millennium's function the script must. Oh, you should put this above. Okay. Yep. Any doubts on this? Are you guys there? There are many left, huh? Sunday night.
No doubts.
Yeah, no doubts. Okay. Let me move to 2D and 3D plotting, which people like a lot. Plots and graphs. Let me create a vector. 1 is to 0.1, 0.001. What am I doing? 0 is to 1 second. X is equal to let's go till 2 pi and sine t. Plot x comma t. Nah. T comma x. Okay. Yes. So this is, I have initialized a vector which goes from 0 in steps of 0, 0.1 till 2 pi. I have defined x as a function of sine t. So sine, these are trigonometric functions in MATLAB. So MATLAB has extensive functions. You can go on and on. I can't even list them for signal processing, for trigonometry, and many things. So I have given that pass the vector. So you see, I don't need to loop it. If I give a matrix, for each of the matrix value, it has computed a value for me. And then plot is a command to plot 2D graphs. Now, before doing this, I prefer always to create a figure. So what it does is it creates a figure every time. Whenever you are using the command figure, I prefer you use close all. Why is it? Because it will unnecessarily accumulate figures again and again, unless you specify the figure number inside this. So if you don't specify a figure number inside, MATLAB understands that you want to create a new figure. So when I run this, it will close the previous one and then now it has created. But now if I just comment this line and I run this, now you see there is a figure 2 and there is already existing a figure 1. Now if I create one more time, it will create one more now, figure 3. And like this, your figures are keep on accumulating and your memory is being lost. So instead of that, you put close all. So it will close all the figures and then you do. So the command is plot for 2D, and you should make sure that the vector size of t and x is always equal. So if you're plotting from a 2D, a slice, you should make sure that both are equal, and then only it will plot, otherwise it will give error. So then if you see this plot, you don't understand what is this plot. I don't know what is this plot, right? Or I don't even like the color of the line. It's very thin. I want to, change the graph a little bit. You can do this here, or you can directly do in the figure. But if you do it here, you know the setting every time, you don't have to change it. So when you go to plot settings, there is a key value pair always. Okay. So you say, I want the line style. Basically, I want it to be dashed. I don't want it a solid line. I want it to be dashed. Right. So now if I run it, you see the line is dashed now. Then there is a command color. Now here you can specify many things, like a combination of colors of RGB values between 256, 256 and 256, or you can use initials or like RGB. So let me make it B. So now you see the line has become blue. If I want to make it a bit thicker, then I say line width is 4. I get thick lines. What if I want to use a marker on it? So you can say marker, I think marker style. I don't remember this. I think it's plus. No, it's not marker style. It's marker. Yeah. So now you see it has filled in all with markers because there are so many number of data points. You don't see them. Let me put it a little bit hazy so you can understand that. Yeah, 63 points. So now you can see it's a dash and like that. And it has covered the entire area like this. There are a lot many options with plots, like you can change the face color of marker, thickness, marker, and these combinations, and so many things which you can try with the help of plot. I'm not giving you much. Okay, then this is for the 2D plots. And yes, now coming to that, now if I want to give a name to the curve, then you can say legend and just give a label. So I can give that this is sine curve. Then if I run this, I get that this is a sine curve. Now, what if I have y is equal to cos of t, and I want to overlap both of them? So what I would say is figure this and then control C. I'll put some color as red. Let me make this a little bit thinner. I don't want this dashed. Make it this and use a marker dot and just plot t comma y. Correct. For now, I'm closing the legend. Now you see it has plotted only one plot. I wanted two plots, but now it has plotted only the cosine plot. Why is it? Because is by default in a figure, MATLAB understands that it has to hold only one plot. So now if you want multiple plots, always use the command hold on. So now if I hold on and I plot it, I get both of them together. Now I want to know what is red and what is blue. So you go inside legend. Inside curly braces, write in the sequence of plotting what you want. Right. So this is cosine curve. And run this. And you get it. This is blue is your sine curve, red is your cosine curve. Like that, you can now name n number of plots in one shot. Now I know that this is going maximum till 2 pi. Why I need till 7? I don't need this till 7, right? So there are limits. So you can set the x limit or you can set the y limit. So you say x lim, I want from 0 to 2 pi. You see, good plot. Like this, you can set the position of this northeast, northwest. In legend, there are controls to put this location. And this is how you can play with this thing. Okay, important things in graphs are x labels and y labels. So you can write x label that it is my time in radians, or it's angle, sorry, angle in right. And then y label is your amplitude. Now you can run this, and this is how you can get the plots. Your x-axis, y-axis is set. You can set the title as well, that this is some trigonometric chart or something like that, and you are done. So that's about 2D plotting and about 3D plotting. So what if I want, this is x, y, t. Okay, so I will say x is equal to time and z is equal to sine t. Will it work? Okay, so you see I have a matrix of 63 cross 63, and these are just my values. And if you want to create a 3D plot out of this, one command is surf, which I like a lot. I'll show you why. So it says I need to specify my x, y, and z. So my x is t. Let me make this as y, so it's easier. X, y, and z. And then just I'll create a figure and then run this. So this is how you get your 3D chart. And there are tools. If you want, you can rotate the 3D. And this is how it is. This is a multiplication of sine and cosine curve with two angles together across. And now if I want to see what are the values, right? So you just say, in this you don't say legend, you say color bar. So when you specify color bar, it gives you what is the scale of these colors. It's going from minus 0.8 to plus 0.8. You can set these values in color bar only, and also set some values for these colors. Like if you want 0.8 to be red, that also you can do. It is a bit tedious, so you should go with the set template. So there is an option called color map, and if I go to the help of color map, please, color map. So in color map, if you go and see, yeah, here. So these are basic templates of color, like hot. If you're doing thermal analysis, hot is very easy. Then if you want jet, then you can use jet colors. So if I just say color map, use jet colors, it will automatically interpolate the colors and show you how the graph can be. So red is more intense, blue is very less. And this is how you can do. You can turn off these mesh lines by surf, I think the edge lines, and that is none. I guess so. Or no. It's edge line. No, there is no edge line. Just one minute. Yep. Surf command and okay, you can do it. I forgot the command for that. So if you give that key value pair, it will turn off the lines and you can see it in a better way. Now, what if you just want to see it as a plate? It is a 3D plot, but you want to see the top view of it. Then you can use contour. And you see, it just shows the level 1 lines of contour. So this is a top view of that plot which we saw in surf, and just the lines of its peaks. If you want the next level of mesh, you can do that in contour, saying that levels you want it as 2, you want 3, you want 4, you want 5. And if you want a contour 3, you can use contour 3. So it will show you like this. So these are just the lines of your basically what you plotted and the first level of it. There is a next level to it. There is a next level. So if you see the mesh, it automatically identifies how it's propagating, and then it shows you like this. So you can rotate this 3D. This is the same thing which I showed you, and this is how it looks in 3D. So there are n number of plots. There is P color, there is contour 3, and other things which you can explore. Yes, we'll wind up on this last one example I'll give. So majority of the times, while you are doing your masters or your bachelors, you will have to solve ODEs and PDEs. I'm going to give you a simple example of ODE. It's a very simple example. So the ODE is y dash is equal to 2t. And given the initial condition that y naught is equal to 0, we know that the solution is y is equal to t square. So if you solve this with this initial condition, you will get y is equal to t square. But mathematically you can solve, but there are certain equations which you can never solve analytically. You can only solve numerically. So in MATLAB, there are inbuilt solvers called ODE 45, ODE 15, ODE 43, and many. I prefer you go with ODE 45. It is based on Rangikutta method of 4-5. I'll not explain you in detail. It's just a method to get a numerical solution of a particular ODE. So if your function is y dash is equal to 2t, you create a function, a test function, which takes two inputs, t and y, and you say dy by dt is equal to 2t. That's it. You say for what time you want to solve it. specify your initial conditions, and then you have to say ODE45 @test function. So what it creates is, it's just like you tag in Instagram or in Twitter, you tag that function or tag a person with @ right? It's his handle name. So this is a handle. That handle pass this t and y naught to this t and y. This ODE45 is an iterative solver. It will solve your entire thing, and then you will get t comma y. You don't need this. And then if I run this, it will give you whatever. Okay, yes. So it has created this plot. This is y is equal to t square plot. So now if you want to see how it evolves, I can actually plot t comma dy by dt percentage figure sorry, I think it has hung. So actually it's an iterative solver. If I just remove this, it will be easier. Yes. So you see, for each iteration, it is actually calculating your dy by dt value and exporting it to t from 0 to 5. So how it identifies the time step, it has its own algorithm, which is called an adaptive time step algorithm. And that is how it identifies the time at which it has to calculate the value and then export it. And that is how it solves this ODE numerically, and you get this graph. So ODE45 is a very strong solver. It's very simple. You create a function, you call it with @, pass your arguments, and that's it. You're done. Any doubts? Sorry, I went too fast in the last one.
In this ODE, we haven't exactly defined the relation of y and t. So,
you don't need to. That is what is the function needs to do, right?
Okay.
So you don't worry what ODE45 does. It will give you, it just needs to know what is dy by dt.
Okay. So we have just put dy dt equals
Yeah.
this. Okay.
So this variable also need not be dy by dt. It can be anything. You can put it a also. So a is equal to, okay, you run this, it will run.
Oh.
So you just have to tell it that it depends on t, okay, and y. You can have y also here, not a problem. It becomes non-linear. I'm not putting that. So you just have to tell it that what arguments it needs, and that's it. And what is the relation between your first derivative and that variable? That's it.
Okay.
And you run it and it will run.
Also, like using MATLAB, can we plot vector fields?
Yes, there is a command called QR. Okay. Yes, let me show you. I don't have data open for that. I can try it for you. QR or vector plot. So this is how it is. This is how it will look like. So let us go to our this thing. Where is that? Yeah. So I can try. We can take. Like this. So there is a command called QR. You can try this. It has like how you want to scale your vectors in u and v direction and your x and y values. So that shows your vector fields.
Also, like in the very first vector plot, t was written as 0 then 0.01, then 2 pi. So basically, the number of points which were being plotted was 2 pi by 0.01 in
Correct,
the.
exactly.
So my doubt was that, like, 2 pi by 0.001 would be basically 2000 pi. But then 2000 pi is like an irrational number. So how is
Yeah.
MATLAB plotting irrational number of points?
No, so it will come to the floor of that value. So you know floor and ceiling, right?
Yeah, yeah.
Yeah, so it will get the floor of that value and then it will go. So if I do 0.1 also, it's irrational, right? So
Yeah.
now if you see, it will not plot, but it has gone to 63 points. That's it.
Okay.
Yeah. So MATLAB understands it. You don't need to have a specific delta to reach a particular value.
Okay.
Yeah. Any doubts, questions? I guess we were 42, now we are 17. I took a lot of Sundays time for everyone. People are not happy.
I know we are
It
pretty
was good
happy.
actually.
Very informative. Thank you so much.
Yep, not a problem. You can reach out to me if you have any problems with it. This was a very basic course. I'm planning to do some advanced course on spectral methods, more of how to play with plots, ODEs of higher orders, and those things. Let's see when it turns out. One optimization problem as well, how to optimize using MATLAB. So
So
yeah,
will we have more sessions on MATLAB?
yeah, soon.
Oh,
Yes, and you can reach out to me. Not a problem. I'll try to help you guys with whatever help I can. Just don't tell me to solve your assignments because I have my own and I have my office work too. So I'll be able to help you with some small doubts if you have while plotting or you are stuck with something in debugging. You're always welcome. I'll
Oh.
stop the share. I'll stop the recording.